Thank you for taking the time out of your busy day to join us in this tech talk on effective rolling stock for fleet management. I'm Robert Henderson. I'm a certified reliability leader, and I'm a rail and transit consultant with Bentley Systems. Now, if you've joined any of our webinars or tech talks in the past, you've probably seen this slide of going digital. I'd just like to talk a little bit about it, about the overall structure of Bentley, where we have CapEx solutions, which is the capital expenditure using microstation design products and project-wise collaboration for project BIM review. And we have our OpEx, which is our operational expenditure, asset performance solutions, which is asset-wise, and together with information exchange, we can have a TOTEX, which is the total asset lifecycle cost, which includes both CapEx and OpEx, and it sort of breaks the barrier between the two groups, and that is done through the connected data environment. Now, I'm going to be spending all my time during this presentation talking about asset performance and specifically for fleet management. But if we look at, asset-wise and operations and our rail and transit needs, we may need, track analytics and forecasting, bridge and structure inspections, facility management inspections, PTC configuration management, and today I'll be talking about our bus and rolling stock maintenance solutions. But beyond bus and rolling stock, we do have many other solutions to help meet your needs. And when we look at our asset-wise product stack, we group them into four sections where we have asset lifecycle information management, ALIM, and this handles the configuration management and change management requirements, and it's really the key to the connected data environment through connecting our design models and sharing that information with operations. Asset reliability really focuses on inspections, asset budget and planning, strategy development, and we get into operational analytics. It's machine learning, linear track analytics, forecasting, and condition indexing. And of course, the solution would be incomplete without enterprise interoperability, where we may need to provide interoperability to existing EAM systems or GIS systems. And I'm going to be focusing on the bus and rolling stock section, which is associated with asset reliability and our asset reliability module. Let me dive into fleet management, and first I'm going to be talking about the asset hierarchy and how the assets are defined in the asset reliability for fleet management solution. So if you already have an existing EAM tool where assets are already assigned to an asset hierarchy, maybe these assets are being defined in Infor, Maximo, SAP, or even JD Edwards, we can piggyback this structure already defined within your organization and use it for our asset hierarchy. So the EAM would become the master of the hierarchy, and we would not create new assets within the fleet management tool unless we absolutely had to. Now, the golden rule for an asset hierarchy from the standpoint at Bentley and from a reliability standpoint is that you define the assets at the level at which you maintain them. So typically for an asset hierarchy, it is unique for each organization, so it meets each organization's needs. So there needs to be some flexibility in the creation of them. If the asset hierarchy being used from the existing EAM system isn't sufficient enough for your solution in terms of a reliability aspect, the fleet management tool can enrich the asset hierarchy, at a more granular level. So we can then pass that information back to the EAM after we have completed that enrichment process. So we do have clients where they discovered that their existing EAM asset hierarchy is at a much higher level than what was required for fleet management. So they decided to use the fleet management tool to add the granular details rather than their master EAM, just because it was easier to do, and it's basically the same result. Now, the tool is extremely flexible to meet yeah, your organization's needs if they want to add, an additional hierarchy. So we can do that with ease. If we wanted to break down the hierarchy at a level by discipline, such as electrical or mechanical, to ensure that different groups in the organization can view the hierarchy in a way that they maintain the assets, this is achievable, and it's easier for different groups to be able to find the information that's relevant to them, and this is part of the asset reliability solution. So interoperability is a key component to the connected data environment, and to ensure a solution meets an organization's objectives. If we have an EAM already in place within the organization for work management and our asset registry, we need interoperability between the systems to ensure really operational assurance. Our own modules within AssetWise Connected Edition have their own interoperability service bus, which is shown here as I hover over my mouse. This ensures that valuable information can flow between our own products. So our strategy development tools for fleet management are associated with the asset reliability module of our AssetWise products here. Now, interoperability doesn't stop there. Some organizations may have their own enterprise service bus, so that's what this item would be. This could be from Oracle or Red Hat. So all applications would have to communicate with the organization service bus. For fleet management, if we need to pull the asset hierarchy from the EAM, we will need to communicate through the service bus to the EAM and back to our own service bus. So there's a flow of information, and this is the information exchange that I have. Now, there could be a case where maybe you want to use our capabilities for a CMMS or work management system, which would eliminate the information exchange here in our interoperability requirement, but there still probably might be a requirement for receiving asset condition data to the system, or even GIS information, as we may want to use that vital information. Interoperability is really a key to success moving forward. Now, dashboards are really about seeing the high-level information across the business to quickly gauge whether or not we are meeting our performance and business objectives. So a key indicator or key performance indicator, KPI, which most of you probably already know about, is a type of performance measurement. So KPIs evaluate the success of an organization or of a particular activity in which we are engaging. So these could include completion rates or compliance rates. These KPIs can be determined in different ways in our asset reliability solution to really meet your organization's needs and meet your organization's objectives from a business standpoint. Now, when we determine our KPIs on the dashboard, these are unique, again, for each organization, and they can even be unique for different business units within the same organization. So we have to align our KPIs with our work management system to see how successful work activities are, but we need to not only understand the reliability of our assets, but we also need to understand the reliability of the business process. So the overall business goals are unique for each organization, and we need to align our reliability program with these business goals to ensure success from the bottom up, but also from the top down, right? So we need to align our site across all units and all levels of our organization. Some indicators will be based on inspections. These could be completion rates or even alarms acknowledged. Let's say, for example, within your organization, if a manual inspection led to a result that exceeded a threshold, which put the indication in an alarm state. if your organization determined that any alarm state based on an inspection has to be resolved within 24 hours, we can determine a success rate or a KPI based on that activity. And these actions could be, to create a work order, or maybe the alarm state requires the asset should be, constantly monitored as a result of reaching that alarm state. Now, what if the value was inputted and it was discovered that the value was not correct? It wasn't the correct value. We can simply create a corrective action saying that the value was inputted wrong, and we can put the correct value within that indicator after as the action or the correction. Now, what if it is broken and the value was correct, but the inspector could fix the problem on the spot? This is also possible where we can have a corrective action as the action of maintenance in real time. We could indicate the before value, which is in the alarm state, and we can indicate the small corrective action that was completed by the inspector, and then of course we would indicate the new value after that corrective action was completed. This creates a historical record of the issue, the values, and this can be used for further analytics for preventative maintenance procedures. So often this type of information is never collected, and it gets lost in that process currently. So we can also have, calculated indicators for our inspection compliance rates or for, fleet fuel consumption. If we see that we haven't been meeting our inspection compliance rate, we can quickly see where we are, and if need be, we can discover why we are having the issues with our inspection process. So we can discover the issue at a high level and then drill down into the data to discover, what the issues are and provide a proper strategy based on logical data results. Now, additionally, we can see our critical assets downtime and uptime rates. So our critical assets are determined based on our criticality analysis, which is also completed within our asset reliability solution. I'm going to talk a little bit more about the criticality analysis in a later slide in this presentation. Now, a little bit more with KPIs and dashboards. This is an example of an actual client's dashboard. So it's calculating the mean kilometers between failures, so the MKBF. So here we are trying to track KPIs set by the reliability authorities to compare how each corridor is doing. So we can compare the matrix between what corridor our rolling stock is traveling. So whether it is the blue line or maybe the red line or XYZ line, whatever you call your corridors, to get an understanding if our track condition is creating our assets to degrade faster. This is a top-down approach from a metrics tracking perspective, right? So we go from the overall track performance and then down to the line corridor performance, and then we can identify our problem corridors and drill down into further analysis. It could be the corridor condition. It could be that there's simply a problem on the rolling stock associated with those areas where we're traveling, or maybe it's a problem with the traction power system on those corridors. But the idea is to get an idea where the problems are and then drill down into the data after. It's really about turning the data into actionable information. And this here we'll drill a little bit deeper. This is identifying bad actors or problem assets. So this example from one of our clients is identifying the bad actors of their rolling stock. So they had 3 bad actors, which were the brakes, which is safety critical, the doors, which is also safety critical, and the HVAC system, which is not really safety critical, but it has a huge impact on customer satisfaction. So we can put KPIs on these bad actors, and we want to monitor these bad actors and these items closely. So I want to talk a little bit about the fleet indicator collection. So when we talk about indicator collection, we can collect this data in various ways. One way is through a calculation, right? So we're collecting data through a calculation. Maybe we need to combine different values or use a basic calculation to determine an average reliability score of a group of assets. Maybe it's a 1 to 5 rating for our state of good repair program. This is easily achievable with our asset reliability fleet management solution. So maybe we also need to consider dates when we're looking at our tire wear on our buses, because rates of wear are different in the summer versus the winter. Or maybe we should calculate this based on accurate temperature information from an available online source. So technology has brought us many new tools for collecting data. So that online source, so we can also leverage that the IoT devices. This would be collecting that data from the online source as mentioned above. This could include current views of pressures, flows, kilometer values of the fleet, or even fuel consumption. So we can take in information from a DCS, which is a distributed control system, and information from a bus or a locomotive's black box. So we can utilize this valuable information to support the organization's reliability program. It is often the fact that most of this valuable information is already available. We just need to put it into a single tool, which then can be used by the right people with the right tools within the reliability team. Many people will talk about this as the dark data that isn't being used but being collected, and we want to maximize the use of the data we're collecting. Now, another form of indicator collection is simply manually entered, right? So this is done by the inspector, and an example could be configuring a ranking score, which would have fixed values based on requirements or regulations for determining how to score that asset. So if an inspector determines that the asset is a score of 3 in our state of good repair program, that value is collected along with all the evidence associated with the inspection of that asset. Now, when determining our assets indicator states, we may also include an alarm indicator, as I mentioned prior. This provides corrective action at the point of discovery. So it's problem found, create work order is a common procedure. This minimizes the amount of time required for a corrective action. So it reduces your downtime, it increases your uptime of your affected assets. Some of these condition states would require no action, or maybe we need to provide an early warning, or maybe we need to provide an urgent warning or an emergency state. Each value can have an indicator that has the appropriate action necessary to ensure really a safe, reliable asset across a much larger network, right? So if the corrective action requires interoperability with an existing EAM work management system, we can tie the corrective action of the asset with the standard work package associated with the existing work management system. So this ties back to the communication between third-party software solutions and the importance of interoperability that I discussed through that interoperability slide earlier in the presentation. Now, this here is another example from one of our clients where they're receiving data from an online source, which is from their door system of their locomotive. So the door system here has a general arrangement with the associated subsystems such as driving arms, tightness set, door leaves, etc. This is shown on the left of the screen, and this asset diagram is used just to to help support the decision-making process. Some of these subsystems can have online data feeding results to our reliability solution. If a meter reading meets a defined threshold that you've determined, we can track and analyze to prepare for potential failure or functional failure of the asset. Now, we can make acknowledgments of that alarm. We can send a message to our enterprise resource planning system to ensure that the problem gets fixed to maintain our uptime of our rail system. This can be done by sending a work order or work request. Additionally, maybe here you can see in the screen, maybe the defined threshold needs an action of monitoring. That can also be an option within the reliability solution. So that would be a monitoring action here identified. So let's take a bit of a moment to talk a little bit about fleet inspection and our inspection management. So our solution needs to be flexible. So we need to add children assets to our fleet assets, such as maybe we need to add mirrors, wipers, and bike racks to our buses, and we also need to track their usage. So let's use an example here. So I'm going to use assets in here, bus 4502 and bus 4503, and I'll mention them through an example. So let's say that, and I'm going to make up an asset, bike rack number 5 for our bus asset 4502. So this requires maintenance. So we need to remove bike rack number 5, and then we need to put a new bike rack number 6 on our asset 4502. Now, we need to track the fact that if asset number 5, bike rack number 5 was repaired, and we need to track and understand if it was determined that it is ready to be installed on a new bus. So let's say bike rack number 5 has now been repaired, and we're going to install it on bus 4503. So we'll install that rack on 4503. We can provide a solution to manage that. However, the assets history associated with that needs to be retained. So because bike rack number 5 has been repaired and put on a new parent, it still needs to track the fact that it was on the previous asset, 4502. So one of our clients adds odometer readings each time the bus is refueled. So not only is this important to understand the fuel efficiency of the fleet, but we can also cascade the odometer reading to each child. So we can get an understanding of every asset and how long each asset has been in service. So remember bike rack number 5, that would have a mileage associated with 2 parents, 4502 and 4503. So we need to be able to track the asset's total life cycle, not just pieces of it. And of course, let's say there's some abnormal wear of various parts, and a proactive action is to get a lube analysis. We can collect these results and analysis and then trend them to ensure a successful fleet maintenance program. So lube analysis is very important, and a very important aspect to asset condition monitoring, or ACM, and it's really a key component to fleet management, which is supported in this reliability solution. So each organization will have its own reliability program. So the solution needs to be flexible and configurable. So the reality is each organization will require to meet different government regulations. So government regulations are regionalized. There are different requirements in various regions, such as but not limited to countries such as Canada, the United States, the United Kingdom, or Australia. These could be FRA or FTA regulations in North America. Additionally, there could be state or provincial regulations. So it is vital that the solution can be configured to meet different regulations. And really, customization only leads to excessive costs when regulations change or new regulations are added. Not only does this customization lead to increased costs for the organization, but it can also lead to serious problems when upgrading or updating the core software product. And for these reasons, a configurable solution is really a key component to success. So perhaps there is a government regulation to perform an inspection when your bus reaches 1,200 miles, and that's up in the top right corner there of our bus asset 4502. This is configurable within the reliability program, and I'm just going to highlight something or bring in a new screen here. The 1,200 mile inspection would have a procedure or a checklist associated with it, which could include tire condition, tire wear, coolant replacement, oil replacement. So these checklists are user defined and are asset type specific, increasing the needed flexibility required for a fleet management program. Now, I said earlier we're going to talk a little bit about asset criticality, and I'll spend some time here. So the best process of developing an asset reliability program is to look at which assets are a high risk depending on safety or environmental or performance-based requirements at your organization. Then we need to develop a strategy with the understanding of our most critical assets. So this here is a screen from one of our clients. So we can really prioritize assets by consequence or failure. Although HVAC is important, again, it isn't safety critical, and depending on your weighting and your risk analysis, it makes more sense to repair brakes or doors of our locomotive first. So we need to use the best principles of reliability by looking at the POF or COF, which is the probability of failure, and then the consequence of that failure if we don't maintain the asset prior to failure. For example, if we can drill into the data and see the failures over the last 2 years, and by understanding our assets, we can identify a probability of failure by using the collected data to forecast the potential risk. This here is another example of a weighting really shown in a visual aspect of safety, environment, quality, production. So it's very flexible on how you determine your criticality of your assets. And risk analysis is really one of the first steps when developing a reliability program, and it is absolutely key to develop a resilient asset strategy. Now, I'll talk a little bit about here, and this is the end user, this is the inspector, this is fleet inspection with simplicity. So for our team in the field to be successful, we need to build tools that are intuitive and simple to use. We can't have a mobile solution that is complex. Many of us are already using mobile devices that are using simple apps that are solving complex problems in today's world, and that should not be different from a maintenance perspective. We are probably mostly familiar with iOS or Android devices. Most of us already have an Android or iOS devices, so we're familiar with the OS, and our app is available on iOS and Android. Now, if we dive into the functionality, the actual tasks are seen on the front screen. They are associated and assigned to the inspector, which is defined by the administrator, and it aligns with the user sign-in associated with that inspector. So these user assignments can also be assigned to entire groups, such as maybe the electrical group or the mechanical group. This ensures that multiple people can perform the inspection depending on the date and time required. Again, flexibility, the flexibility component is key to success here. Now, the inspector only sees, what tasks they're responsible for, how far along they are in each inspection, and the associated due date. And the list is very simplistic and straightforward, with the highest priority listed at the top. So the inspector would, select an inspection, and then they would be responsible for then going in through the check sheets. They would go through the check sheets of all the responsibilities. Each check sheet would have, different types of indicators for that inspection process. Now, the inspector would be responsible for filling in all the indicators associated with that inspection procedure and define ratings, include notes if necessary. The mobile application also includes, asset rating history, so the inspector can see what the last reading was, for example, and when it was collected. The system is meant to simplify the process and standardize the results. If at any moment the inspector feels that, I need to take a picture of this, he just simply takes a snapshot. That picture becomes part of the inspection results, and it includes very valuable visual information for anyone reviewing the results. And because, as they say, a picture is worth 1,000 words. And lastly, how can we ensure that the inspector is actually inspecting the equipment? And this can be achieved with barcode technology, and the asset reliability mobile solution does have that capability baked into it. Now, depending on the criticality of your assets, we may need or want to go into more advanced methodologies associated with reliability strategy development. So AssetWise Reliability already has these capabilities baked into the product, and we have many years of experience supporting such methodologies as an organization. In terms of first steps of strategy development, it's usually defining our current practice review. To start somewhere, we need to understand the current baseline, determine what you're doing today, determine if it is valid, and take that paper check sheet list and digitalize that process. So document any procedures that are done by your subject matter experts that are not documented, and digitalize those workflows. What do you currently do with the inspection data? How can we improve the process currently in place? As your organization matures in reliability, the current practice review functionality will allow your organization to continuously improve, and that's what reliability is. Now, as we mature, we may need to perform more advanced methodologies associated with reliability. A common one is root cause analysis. Now, asset reliability will support those RCA needs. To move towards a reliable system, we need to stop fixing the symptoms on our critical assets, and there are several RCA methodologies we can use. One of them being failure mode and effects analysis, or FMEA. An FMEA solution is often the first step of a system reliability study. So it involves reviewing as many components, assemblies, and sub-assemblies as possible to identify failure modes and their causes and effects. For each component, the failure modes and their resulting effects on the rest of the system are recorded, and specific FMEA worksheets are created. Now, reliability-centered maintenance, or RCM, is a popular methodology to achieve improvements in files such as the establishment of minimum safe levels of maintenance. It is defined by the technical standard SAEJA 1011, I think. So when successfully implementing an RCM program, an organization typically sees increased in cost effectiveness, increased reliability, increased uptime, and a greater understanding of the level of risk that the organization is managing. So this relates to improved safety, and we've actually seen that successful implementations in the airline industry to solve many of their safety-related problems back in the 70s and the 1980s. So RCM is a methodology for a more mature organization moving towards level 4 of the 5 levels of organizational maturity. And I'm going to talk about those levels later in this presentation. Now, baked into asset reliability is a root cause analysis solution, and this here is an image of it. So it sort of acts as a digital sticky note module to perform root cause analysis. So this is a common system with our subject matter experts as we drill down into a problem using sticky notes. However, this is a digital form for that powerful function. It's very similar to the 5 whys principle of a very simple RCA methodology. So if you find a problem and you ask why the problem is happening, 5 times, you're likely to come to the root cause. So once we've found the root cause of the problem of our critical assets, we can link the root cause back to our strategy for optimization of our reliability program. So, this is where RCM is very beneficial. RCA. Now, when we talk about RCM, RCM can actually seem like a very daunting task and a very big task for an organization to start with. Even if you don't have a deep maturity in reliability-centered maintenance, it can be a tough task. So usually, failure mode effects analysis can be a smaller acceptable step moving forward with the reliability program. So we can set up, FMEA templates that are associated with our critical assets and critical systems. If we have information available on our critical door asset, for example, that was used earlier, it becomes easier to implement an FMEA methodology associated with the door system. So we can flag certain issues and give you the required amount of time to recognize the problem, which empowers the reliability engineer to schedule the maintenance at the right time before the functional failure, providing effective maintenance of that door asset. Now, if you ever heard or if you ever hear someone saying machine learning and artificial intelligence will solve all your problems, they probably don't know what your problems actually are. So we applied machine learning with the door systems actually with the same client that was being used here, and it was actually proven to be not very successful. We could predict when the asset was going to fail accurately. The problem was the prediction didn't give enough time for scheduling the repair. So it could predict it a few hours prior. And there's many areas where we could use machine learning to benefit our reliability program, but it's not something that can be used everywhere, or probably it shouldn't be used everywhere. So with our door system, it's an example of if we have a good program, a robust process, which goes by engineering principles in combination with our detailed analytics, we can solve those problems. Now, a little bit about digital twins, and digital twins really are changing the world of operations and design. However, when we talk about operational digital twins or performance digital twins, this may be something some of the older subject matter experts may not be interested in or may not be impressed in. But as a new generation enters the workforce, this is something that is extremely beneficial, not only to for educational purposes, but it actually helps employee retention as the new generation demands using the latest and greatest technology. Additionally, being able to visualize the asset at the desk during your analysis before going on site can be extremely valuable and can save a lot of time. This example in this slide shows an iModel intelligently link within the assets in the asset hierarchy and asset reliability. So the bogey asset, along with the connected assets, are highlighted in the iModel, which we could show the associated alarms or indicators for that asset in the model. We are already using this technology with many clients, and the iModel digital twin technology for operations we've experienced endless possibilities as a result of some of our clients. I shouldn't say endless, but we realize we can do a lot more than what we could originally. So a little bit about the 5 levels of your asset, your asset reliability program. As you mature, our products are able to handle that maturity level. So a common in the rail and transit industry is run to failure and then fix. It results into the much higher costs associated with an asset failure and the downtime of the assets. That being said, there's actually reasons why you would want run to failure. So this would be on assets that are the lowest criticality and assets that are very easily replaced. So downtime associated with these assets do not cause an organization to lose money or become unsuccessful. So this could be an asset, for example, like a dishwasher or a fridge. We can just, food will go bad for a day and we'll go get a new fridge at Home Depot. It's easily replaced. Now, when we look at preventative maintenance or basic compliance, this is our PM programs. This could be achieving state of good repair, proving that you're compliant. These could be requirements associated with FRA or FTA. So this is basic compliance, and it usually results in collecting data but doing nothing with it. It's basically a checkbox. Currently, most organizations meet level 2 with their current solutions, but if you have not yet to meet basic compliance requirements, we can always help you with meeting those requirements and achieving level 2, and you can be assured that our solution will go beyond level 2. And that's where we go into predictive maintenance and asset health indexing. Once we enter the realm of predictive maintenance or proactive maintenance and health indexing, we will need more powerful tools that can analyze collected data during our fleet inspections. It is in this realm where asset reliability for fleet management can help you achieve your goals. We need to understand the historic asset condition, current asset condition, and the trend of that asset, so we can predict into the future and understand of when our assets are going to potentially fail and understand that risk. Now, asset strategy development is implementation and management is our level 4, and when we look at level 4, we can now use our current practice review to go beyond understanding of how we're meeting current regulations, but use these tools to understand where we need to be and how we can continuously improve. It also includes other reliability strategy development tools, and these are used on our most critical assets that will cost our organizations the most if they fail. So we need to increase their uptime. These methods would include root cause analysis, failure modes and effects analysis, and reliability-centered maintenance, as mentioned prior in the presentation. So optimization and predictive forecasting is level 5, which includes the methodology, again, of continuous improvement, the mentality of moving towards perfection and knowing perfection doesn't exist, but that's the goal, and that's how you continuously improve. Again, the point of this slide is that we have tools that can mature with you. We will continuously work with you and move towards reliability with you. As you move towards continuous improvement, increasing your organization's reliability, which will increase your performance and safety across your entire organization. And it's really about the fact that your success is our success. So we can align our goals together. We can develop a success plan. I mean, these are gigantic groupings here, but we first need to define our business and reliability needs. We need to develop a digital fleet management reliability program, and of course, we need to execute fleet management and that program. And the goal here is not to sell you a solution and then run away. The goal is to work with you from the start to the finish.